Hi there, today I'm going to go through some questions in geometry chapter 5. So for our first example, we're supposed to calculate angles 1, 2, and 3, knowing that we have a set of parallel lines. We know that the lines are parallel because of the arrow here and here. So here are my first three angles. The 77 is due to the fact that 103 and 77 have to add to 180 degrees because these two angles are supplementary. This 103 is across the vertice from that 103. So these are called vertical angles, and vertical angles must be equivalent. Over here, again, 142 and 38 have to add to 180 degrees. So these are called supplemental angles. Next angle I'll calculate is the 39. I got that because these three angles form a triangle, and then that means that they must add to 180 degrees. Next is this 103. The C stands for corresponding. The 103 degrees here is corresponding with the 103 degrees here. And once I know that this is 103, then since it's across the vertice, this is also 103 by vertical angles. This 39 is across the vertice from this 39, so we can say that by vertical angles, this must be 39 as well. And then finally, these two angles have to add up to 77. So if you take 77 minus 39, you get 38 for angle 3. All right, for our next example, we're given two sets of parallel lines, and we're supposed to calculate angle 1. First of all, by corresponding angles, I can say that this angle here is equal to 3x plus 5. Then, since 3x plus 5 is supplementary to 4x, that means they have to add to 180, and I can write an equation that says 3x plus 5 plus 4x equals 180. By solving that equation, I get x equal to 25, and then that means that angle 1 must be 35 because it's going to be corresponding with x plus 10. So 25 plus 10 is equal to 35. All right, here we're given that ABCD is a rhombus, and we need to calculate the x. So one thing that we know about a rhombus is that this angle right here is 90 degrees. So the diagonals of a rhombus cross at a 90-degree angle. That means that we have four right triangles here. We also know that in a rhombus, this angle is equal to this angle, or that a diagonal bisects. And that's not true in every quadrilateral, but it is true in a rhombus. So I can write the equation that 2x minus 1 plus x plus 1 plus 90 equals 180. And then solving that, I get x equal to 30. All right, here we're supposed to assume an isosceles trapezoid. That means that the base angles are equal. And we need to calculate the area. To calculate the area of a trapezoid, we add the bases together, we multiply by the height and divide by 2. So I'm going to draw a line in here for the height of the trapezoid. And then I'll calculate the distance from right here to be 2.2. I got that by finding the difference between the top and the bottom, 10.4 minus 6, and then dividing that difference by 2. Then I can calculate the height to be 3.7, and this was done with the Pythagorean theorem. The square root of 4.3 squared minus 2.2 squared. Now I can use the formula, take the height, multiply it by the bases added together, divide by 2, you get 30.34 inches squared. Finally, for example 5, I'm given that ABDF is a rhombus and BCEF is a square. Again, using the properties of a rhombus, I can calculate angle 1 to be 90 minus 23, which is equal to 67. And then I can calculate angle 2 by the fact that these two angles have to make a right angle. So 90 minus 67 is equal to 23.